Right, now we're going to move on and look at bonding, actual bonding taking place. Now remember, we've done this in physics, we've spoken about electrostatics, we've spoken about the attraction between different charges, and that is the basis of chemical bonding. And we're going to show you how this comes about. Let's look at that common molecule, sodium chloride or table salt. Now, we're talking about sodium chloride. Now let's just remind ourselves, sodium has a Lewis structure which looks like that. One single electron, one single valence electron, and remember that term. And these are the electrons that do all the interesting stuff. Valence electron there. So there's just one of them. And then we're going to look at chlorine. Now, chlorine's quite a big chap, and chlorine has 1, 2, you'll remember where it is in the periodic table. It's 1 away from the noble gas arrangement. So it has 7. In fact, it has 8 less 1. And there we go. So it's got 7 electrons. Now we're going to make models of these and see what... Okay, Tanuka, you've actually prepared them for us, haven't you?
I have done that, and this will be our chlorine.
That's your chlorine.
Atom, and that will be the sodium.
Okay, the color coding is not quite correct, is it? Because very often they talk about chlorine as being a greenish colored gas.
Yeah,
all right.
Yeah.
Well, our green atom is the sodium, and our yellow atom is the
chlorine atom.
You see here, 1 electron. One electron.
And with me here, 1, 2, 3 pairs, 6 plus the 1, so I've got 7 valence electrons for chlorine.
Now what's interesting there is you see that these are distributed out over the surface of this. In fact, what that would be representing is the nucleus plus the inner electrons, and these are spread out. Now let's just go back and talk very briefly about that idea electronegativity that we mentioned last time. Now just remember, now let me show you here. Okay, remember we spoke about electronegativity, and electronegativity is really only spoken about when we have 2 atoms bonding to one another, and we're talking about the bonding electrons, in other words the electrons that sit here between the 2 nuclei or the 2 atoms. And these numbers give us an idea about how strongly 2 atoms will hold onto their electrons. So really what we've got to look at is the difference between these two. Let's say hydrogen and fluorine will bond. We see there that there is a difference of 1.9 between these. Fluorine is obviously an atom which holds onto its electrons very, very strongly. Hydrogen strongly, but not as much as fluorine. If you get hydrogen and oxygen bonding, as we do in water, and we will talk about that later, you see the difference is 1.4. That is still regarded as a fairly big difference. If you get, on the other hand, oxygen bonding with oxygen to make an oxygen molecule, well, of course the difference is neither. So neither of the 2 atoms in an oxygen molecule would have any greater attraction for the electrons that are being shared between it.
So in that case we'll have a fair share of the bonding or the bonded electrons
would find themselves equally distributed around either or between either of the or between the 2 oxygen atoms. Now we're talking about sodium chloride. Sodium and chlorine bonding. Look here, 0.9 and 3. What does this tell us?
That tells us that chlorine is going to attract the bonding electrons more towards itself.
Okay, more strongly than the sodium when they get together.
Yeah.
So now we have the setup. You're chlorine, and you've just dropped an electron. It happens in the best of Christian families.
Let me see. Where is the
was that an extra?
That was an extra. I've got 1, 2, 3, 6, and my 7.
Okay, and there's the 7th. We'll put him over there.
There.
Okay. Now, sodium this one electron, chlorine, one unshared electron there, and chlorine has got a big attraction. So what's going to happen is
that electron is attracted to the chlorine atom, and
now
there we go.
Chlorine has an extra electron, so it's got one more electron than it has protons in the nucleus. So its overall charge is
negative. It has got an excess of
one
minus
electron.
1.
So it's got a charge of -1. This,
Yes.
on the other hand, has lost an electron, so it has fewer electrons altogether than it has positives right in the nucleus, in the center of that. So it is overall positive. That is a positive ion. Tinyiko is holding a negative ion. Positive and negative attraction. That attraction is the bond.
That's the bond.
Okay.
So this bond is actually depending on the electrostatic force between the two ions.
Okay, ionic bonding. Now we're going to show you the bonding in which there is not much attraction, much stronger attraction from one than from the other. And in that situation, we will see something different happening. We're going to take as our example methane, which is carbon bonding with hydrogen. And we'll see now how many of them. First, let's look at the Lewis diagrams. Okay, here is the situation in which we got ionic bonding. Now, carbon, you will remember, has 6 electrons altogether. 2 of them are sitting in the inner shells close to the nucleus, which is very, very tiny. And it's got 1, 2, 3, 4 electrons around the outside. Hydrogen, on the other hand, has one electron. It's only got 1 electron. Now, hydrogen has an electronegativity of 2.1. Electronegativity of carbon is 2.5. Not a very big difference. Therefore, carbon doesn't have any greater hold over its electrons, its outer electrons, than hydrogen does, really. So let's have a look and see what happens now.